Hey everyone, and welcome back. As developers, we spend so much time building features, optimizing performance, and making our applications shine. But what about the heart of it all, the database? If your database isn't secure, all that hard work can be compromised in an instant. Today, we're flipping the script. We're going to dive into the most common database hacking techniques, not to teach you how to be a black hat hacker, but so you can understand how attackers think, and more importantly, how to build impregnable defenses into your applications. Every developer must know these .SQL injection, the classic vulnerability first up, the granddaddy of database attacks, SQL injection, SQL. This is a technique where an attacker inserts malicious SQL code into input fields, aiming to trick your application into executing unintended database commands. Imagine a login form. If you don't properly validate user input, an attacker might type something like or1 equals 1 into the username field. If your application simply concatenates this into a SQL query, it could become select asterisk from users where username equals or 1 equals 1 and password equals. The 1 equals 1 part is always true. Bypassing your authentication. SQL can allow attackers to bypass authentication, log in as any user, even an administrator, extract sensitive data, dump entire tables, including user credentials, financial records, or private information, modify or delete data, alter records, deface websites, or even wipe out your entire database. Execute arbitrary commands. In some cases, SQL can even be used to execute operating system commands on the database server. Broken authentication and session hijacking next. Let's talk about broken authentication and session hijacking. This isn't strictly about database hacking, but it's a common pathway to database access. Weak authentication mechanisms, like easily guessable passwords or default credentials that haven't been changed, are low-hanging fruit for attackers. Brute force attacks, where an attacker tries thousands of password combinations, can often succeed against weak passwords. Once an attacker gains valid credentials, or if they can intercept a user's session token, for example, if sessions aren't properly secured or are transmitted over unencrypted HTTP, they can hijack that session and act as the legitimate user. This often gives them direct access to the application and, by extension, the database, with all the privileges of the compromised user. Insecure direct object references, IDOR. Another subtle but dangerous vulnerability is insecure direct object references, or IDOR. This occurs when an application exposes a direct reference to an internal implementation object, like a database ID, and fails to properly verify user authorization. For example, if your URL looks like www.example.com/users/profile?, ID equals 123, and your application simply fetches user data based on ID equals 123 without checking if the current logged-in user is authorized to view that specific ID, an attacker could simply change ID equals 123 to ID equals 124 to access another user's profile. While not a direct database hack, it's an application layer flaw that can lead to unauthorized data disclosure from your database. Privilege escalation. Even if an attacker gains initial access with low-level privileges, they'll often attempt privilege escalation. This is the process of gaining higher-level permissions than they initially had. This can happen by exploiting misconfigured database roles, using known vulnerabilities in database software, or by leveraging default permissions that are too broad. For instance, if your application connects to the database using a user account that has delete or drop table permissions when it only needs select, an attacker who compromises that account could wreak havoc. Attackers are always looking for ways to move from a basic user to a database administrator. Unpatched software and misconfigurations. Often, the simplest hacks are the most effective. Unpatched software and misconfigurations are ripe targets. Database management systems, DBMS, operating systems, and even third-party libraries often have known vulnerabilities. If you're not keeping everything updated with the latest security patches, you're leaving open doors for attackers. Similarly, default configurations often prioritize ease of use over security. Leaving default administrator usernames and passwords, or exposing database ports directly to the internet without proper firewalls are glaring misconfigurations that attackers actively scan for. What developers must do. Your defense strategy. Now that we've looked at the offensive side, let's talk about how to defend. Every developer needs to build security in from day one. Use prepared statements and parameterized queries. This is your number one defense against SQL injection. Instead of concatenating user input directly into your SQL strings, use placeholders. The database engine then treats the input as data, not executable code, preventing malicious commands from being run. Most modern languages and ORMs support this. Implement input validation and sanitization. Never trust user input. Validate data, types, lengths, and expected formats. Sanitize input by escaping special characters or only allowing a strict white list of characters. While not a standalone defense against SQL, it's a crucial first line. Enforce the principle of least privilege. Your application's database user should only have the absolute minimum permissions required for its tasks. If your app only reads data, don't give it insert, update, or delete privileges. Similarly, your database administrator accounts should be separate and highly secured. Regularly update and patch software. Stay on top of security advisories for your database system, operating system, and all related libraries and frameworks. Automate patching where possible. Secure your authentication. Enforce strong, unique passwords. Use multi-factor authentication, MFA, where feasible, and limit failed login attempts. Never use default credentials. Implement proper access controls. IDOR prevention for every data request. Always verify that the authenticated user is authorized to access that specific resource. Don't rely solely on exposed IDs. Monitor database logs and audits. Enable logging for database activities and monitor them for unusual patterns, such as repeated failed logins, unusual query types, or access from unexpected IP addresses. This helps detect attacks early. Avoid verbose error messages. Don't expose detailed database error messages to your users. These can provide valuable information to an attacker about your database structure. Generic error messages are always safer. The digital world is constantly evolving, and so are the threats. By understanding these common database hacking techniques, you're not just a coder. You're a cybersecurity advocate building resilient, secure applications. What database security best practices do you swear by? Let us know in the comments below. If you found this video helpful, please give it a thumbs up, share it with your fellow developers, and subscribe for more insights into building secure and robust software. Thanks for watching, and happy coding!